Hi everyone, Dennis Foley from Acoustic Fields. Today we're going to talk about the 5 common acoustical mistakes we see in most small room studios today. So these are the top 5. I'm sure there's many more, but these are some that we've noticed, and I think a little explanation about what they are and maybe why people think that they're okay to do might help go a long way towards some more understanding. Low frequency management. I can't stress enough how important this is in a room. There's a lot of energy from 30 to 50 hertz, 30 to 60 hertz. And if you're not hearing that with the same attack and decay as your middle and highs, you're really missing out. And most rooms won't let you hear it. Room setup. I see a lot of rooms set up for ease of operation and usage with no concern or care taken for acoustic situations. Are you in a mode? Are you in a high pressure area? Are you in a low pressure area with your monitors, with your listening or seated position? All these things have to be taken into consideration. I see a lot of rooms set up just because it looks good. Well, that's a consideration, but it should be the last consideration on your list if you're making a living in this room or enjoying music in this room. Let's put the music first. Absorption rates and levels. I see a lot of people out there who think that 100% absorption at certain frequencies is important, and then they carry that 100% absorption through middles and highs, and it's just simply not true. Energy management within a room has to address the rates and levels, both, in managing that energy. You can't just absorb energy and convert it to heat and destroy it. Well, let's put destroy in quotes because you really don't destroy energy, but you change it into heat, and for our purposes in our room, you lose things because once it's absorbed, it's gone forever. Floor and ceiling reflections. I see a lot of people out there, they get the sidewall reflections are really important. They get the front and the rear slap back at the monitoring position, especially the rear wall. But they completely forget about the floor and the ceiling. Those two surfaces count for about 18 to 20% of what you're hearing in your mix. So you have to be very, very concerned with floor and ceiling reflections because they're the closest boundary surfaces to you. So you want to make sure that those areas are addressed. So let's look at each one a little bit closer, and maybe we can get a handle on some tighter definitions, and with more understanding and knowledge of how important these 5 are, I think we can have better room acoustics. Okay, let's talk about low frequency management, because low frequency is a problem in almost all the rooms we see. Why? Because you simply don't have volume or dimension. Real estate's expensive. People are making music and producing music now in small project studios, bedrooms if you will. So we really have to focus on, okay, it's a small room, so we're going to have big low frequency problems. So we want to make sure that we have proper low frequency management in these rooms. There is a lot of information from 30 cycles to 50 cycles in our music. There's a lot of information from 30 cycles to 60 cycles in our music. And that is very, very critical to get right. There's a lot of information there, and it's very important to the emotional involvement of our music, whether we're a professional and making the music, mixing it, or someone on the other end that's in a playback environment listening to it. That low frequency attack and definition is critical to the emotional connectivity in the music. I would argue just as important as the middle and high frequencies. Everyone says the middle frequencies are where we identify with as individuals, as human beings, where we connect with the music. Well, yes, that's true, but the low frequency area has to be defined. And you also have to have the same separation, the same attack and decay that you have with the middle frequencies. That's critical, and you can get that. Technologies are available today. Not many, but there are technologies out there. Diaphragmatic absorption is one of them, the one that we use. There are a few others, but there are technologies available that will give you that attack and decay that you have with your middles and highs. Yes, they're heavy. Yes, they take up a lot of space, but they will work and they will help you manage low frequency energy. And like I said, the low frequencies are important in your mix. You can't dismiss them. You have to have complete control over them. I know it's frustrating, especially when you're working in small rooms. Everything is always a workaround. You're always working around this problematic frequency or that problematic frequency. Well, I understand that, but there are ways to address those issues and make listener fatigue and clarity and definition and separation really, really important. And you know, that's quite possible with the state of acoustical technology today. Treatment myths, be very, very careful. Boxes filled with building insulation foam, they are not low-frequency absorbers, at least not in our definition, which is all energy in a small room below 100 cycles. We use that as our dividing point because different treatment technologies are necessary for below 100 hertz, and different treatment technologies are available or are necessary for above 100 hertz, and you can't mix them. They're not all-inclusive. One works one way, one works the other way. You can combine the two technologies, but saying that foam and boxes filled with building insulation are low-frequency absorbers does everyone, novice and professional alike, because it gives the novice bad information that he will rely on. He'll buy product, get them in his room. We see this every day, and they're not happy. Well, they're not happy because they've been misled. And that's the big part and the reason they're not happy. It does the professional in service because it gives us headaches. It gives me a headache. Okay, our second common myth, room acoustic myths that we see in small room environments is the setup. We touched a little bit upon this in the introduction, but room setup is critical. Let's not set our room up based on what looks good, and let's not really set our room up on what works best for us, even though working best is part of the situation. Let's make the music and the sounds that we're creating within the room the top priority. In order to do that, the left and right channel and the seating position act as one unit. One unit. They're not separate. And each of these three parts has particular needs within the room. And they must be created and dealt with as a single unit. You can't have one speaker closer to one sidewall than the next. Sound travels at a constant speed. We must be able to predict the speed of those reflections in order to manage them correctly so that they don't interfere with the direct sound. So we need equal distances so we have consistency and predictability in our acoustical treatment proposals and what we're trying to accomplish. Because we have room sound that we must take into consideration. So we have this sound triangle, if you will, the left and the right channel and the listening or monitoring position. That's viewed as a unit. That unit has to sit within a room that has a certain dimension and a certain volume. Those two things have to go together. They have to fit together. If they don't, you're going to struggle with certain frequency anomalies, spatial irregularities in the response. You've got to get this right. And there is a few positions that work very well. And we can help you figure out what those are. But mainly, keep the left and the right channel and the listening or monitoring position as a single unit in your room. Keep that area, as you move it around, you're moving everything together. There's an equal distance here, here, and here, and then there needs to be equal distances here and here for the room, and here, and here. So this whole unit must be dropped into the room. Take the roof off your room, drop this whole sound triangle into the room, but put it in the right position that works acoustically for the room, that achieves the smoothest frequency response. Or else you're just running uphill all the time. Don't go for what looks good. Don't go for what good usage is right away. Start with the acoustical need. And then there's always going to be a compromise. You'll overlay then the usage need over the acoustical need and try to find a working compromise. Okay, our third myth that we see a lot of times is the absorption rate and level that we touched upon in the beginning. There seems to be a school of thought out there that absorbing all the energy in order to manage it is a good idea. Well, I'm going to take the position that it's not a good idea, that low, middle, and high frequencies each have their own rate and level need. Now, you can say, well, we need to absorb all the low-end energy that's causing a problem. Well, maybe, maybe not. Maybe it's not all the low-end frequencies that are causing the problem. Maybe it's a few frequencies in a certain position in the room that are playing havoc with the rest of the frequencies in the neighborhood, so to speak. So maybe that's not the case. As a general rule, it's probably safe to say that a lot of absorption is needed in the lower frequency area. However, in order to do that, it requires a large amount of space. So getting a low level of absorption is pretty easy to obtain. Getting a high rate of absorption within the same amount of space is a completely different issue. So level and rate, both very critical. Yes, we need to get down to the frequency. We need to design the technology with the design parameters to get down to those frequencies that are problematic. But we need to do it, and we need to do it in a rate that is conducive to what we're doing in the room acoustically and musically. In our studio, I have now 3 12-inch subwoofers in an 18 by 18 by 8 room. I know, bad room, a square, purposely built that way. I have no low-end response below 50 cycles with 3 12-inch subwoofers. Now, the room has 4,000 pounds of carbon in it and is filled with low-frequency management products, but I can peel back these layers and achieve certain things with the low end of the room. So it can be quite dramatic. It can be, for demonstration purposes, quite smothering with the low end. But I did it to show people that you do have control over this rate of absorption, and it's critical for lows, middles, and highs. You don't have to destroy energy. Now, I'm not saying destroy energy, but changing it to heat to a different form, in effect, is kind of destroying it. We take the acoustical energy through absorption, run it through a box of building insulation, open-celled acoustic foam, and we convert it through heat, and it's changed form. So in essence, it is destroyed musically because we can't hear it any longer. It's been changed to heat. So we want to be very, very careful about destroying energy, quotes, in order to manage it. Think of the price you pay for your amplifier. Think of the price that you paid for your speaker, your cables, your converters, your source materials, your board. Do you really want to, when you calculate the per watt price, do you really want to absorb all of that energy that your equipment is producing in the room simply because the room isn't cooperating? I don't think so. Let's find a balance here between acoustics and music, and always keep our music. Hi everyone, now we're going to talk about the fourth myth, the fourth acoustical mistake we see in small rooms all the time. And that's the disregard for the impact of the floor and ceiling reflection. Now, if you think about this, we're always talking about sidewall reflections interfering with the direct sound from our speakers, but if you really think about it, the floor and the ceiling reflection reach the listening position before the sidewalls. Why is that? It's closer. You're sitting on the floor most of the time, so you're very close to the floor. So the reflection off the floor is hitting you before the sidewall reflection is. Ceiling, usually the same situation. So distance to the surface, the boundary surface of the room, is critical, and floor and ceiling are very critical. In our testing and listening tests and voicing tests, we think it contributes about 15 to 20% of what you're hearing, these two reflections. So it is very critical, and we want to be concerned about it. It's not really talked about that much. It is in professional recording studios because the ceiling is a good place to put low-frequency absorption. It's out of the way. Low-frequency absorption takes some space. It's out of the way. It's on the ceiling. You're not having a bunch of freestanding units standing around getting in the way, especially in our smaller studios. So that's a good place for low-frequency absorption to be placed. The reason it's not talked about too much, and the reason it's left kind of till last, if you will, in the treatment scope of things, is that we hear mainly in this lateral horizontal domain. I mean, we do hear vertically, but the lateral domain, because of the way our ears are positioned in a vertical array, is really where our focus is. It's kind of our hearing domain, if you will. So we're more sensitive to those sidewall reflections and how they interfere with the direct sound from our speakers. So naturally, we want to treat that. And everybody has been told to do that, so people are naturally moving in that direction. But the floor and ceiling are very critical. And those individuals that have treated the front wall, the rear wall, and the side walls correctly, depending on the room usage and objectives, when they do treat the ceiling and the floor, they really hear a big improvement because it's important, and it's the first reflection that arrives at the listening position. Issue that we see in small room acoustics a lot is room size and volume. Now, I know real estate's very expensive, and we try to do whatever we're doing musically, mixing, playing in small rooms. We have to, because real estate is expensive, and there's just nothing a lot of us can do about that on limited budget. So we will choose a room because it's convenient, it's not being used, it's available. Well, none of those criteria will work acoustically. They'll not give us any kind of benefit acoustically. We have to look at the low frequency issues in the room. How is the room with its dimensions going to be able to handle a 30 cycle, 37-foot long wave? That's the true test. How are we going to get it to handle that 30 cycles? Well, we could say let's go down to 20 cycles, but there's not that much energy below 30 in today's music format. So unless it's classical and or pieces like that. So we don't want to work with anything like that. Let's start with the 30 cycles and make sure that the room dimensions that we have will allow for that 30 cycle wave to fit. Okay, and there's all kinds of criteria for that. There is a ratio of room dimensions that works well from the beginning. There are ratios of room dimensions that simply will never work. And I see this constantly in the forums. People tell us about the room size that they have, and there's just simply, and all the problems they're having, and there's just simply no way, even with a room full of acoustical treatment, with today's technology, is the person going to be able to have any kind of low-end management or low-end relief in that room. So it's best that they choose another room. And, you know, that's our philosophy. We have a database of 116 rooms that we've built. The bottom third are just taboo. There's so many acoustical distortions that if you send me your room size and I see that it's in the bottom third of our list, I'm going to tell you to find another room. So you don't have to go through the same mistakes and make the same mistakes that we did. The middle group that we have is a balance between what can sound good when what works dimensionally. So it's like 50-50, good and bad. But with proper treatment, the room can sound good. And then the final group, is a great start with no acoustical anomalies, and it's just a matter then of reflection management. So watch the ratio of width, height, and length when you choose your room, because music needs space, especially low frequency energy, and there are certain dimensions that it simply does not like. And if it's not happy, you're not happy. And you will be continually working around it, especially below 100 hertz, and it will be always an uphill battle for you.